Hi friends, welcome to the Unit 3, Day 3 notes. In this particular video, what we're going to do is we're going to talk about how to find all of the zeros for a polynomial, and then how to write it in factored form using technology. So you're going to need your graphing calculator for this particular part of the notes. So what I want to do first is find all of the possible rational zeros. So we're going to use the rational zero theorem that we had from earlier. It's the factors of, in this case, factors of 10 over the factors of 1. Now, first we want to make sure that it's in standard form, and it is. So the factors of 10 over the factors of 1, well, factors of 1 is just 1 and negative 1. So really we're just looking at the factors of 10. So the possible rational zeros for this one are going to be plus or minus 1, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Those are all the possible rational zeros. So now what I'm going to do is I'm going to graph this equation here. Let's go to my y equals. I'm going to graph that x cubed minus 4x squared minus 7x plus 10. Now when I go to my graph, I may not be able to see all of them, so I may have to access the window to adjust. For this particular one, what I want to point out, I'm going to try and make it, push the wrong button, there we go. Try and make it so you can see it easier. So what I want to find here is I want to find where it crosses the x-axis. So in this case, looks like it crosses the x-axis 3 times. I'm seeing all 3 of them, and that's good because it's x cubed. Now, you may not see it multiple times. We'll talk about that with multiplicity. So here, the x-intercepts, the way that we can find them is to go to second, calc, and then 0. And then from here, what I want to do is I want to go to the left of this intercept, press enter. Then it says right bound. I'm going to go to right of that intercept, press enter. It says guess, I can just press enter. And it tells me that I have a 0 at negative 2. So I have a 0 at negative 2. I can do this again with my other values, and I'm confident that that is actually a 0 because I didn't see a decimal point afterwards. In this case, I also have a 0 at positive 1. Now let's see if I can get a 0 for this last one. There may be a case where you get what looks to be like an irrational 0. And if that's the case, what we would have to do is we would have to go back and use synthetic division to find all the zeros until we get a quadratic and then solve to find the remaining zeros. For this particular instance, though, we have a 0 at negative 2, 1, and 5, and that matches our possible rational zeros that we found earlier. So this tells me that this polynomial factored out completely is going to be x plus 2, x minus 1, and x minus 5. So that is that polynomial factored out completely. For number 7, the possible rational zeros. Now we're going to see where this one brings in a little bit diciness to it because our leading coefficient this time is 3. So we're going to have the factors of 4 over the factors of 3. Now the factors of 4 are going to be plus or minus 1, 2, 4, and then the factors of 3 are 1 and 3. So when I list all my possible rational zeros, I'm going to first start with my values that are fractions. So that's plus or minus 1/3, plus or minus 2/3. And then continuing on, let's see, we're going to have plus or minus 1, plus or minus 4/3. And then I could have plus or minus 2, and then also plus or minus 4. Those are my possible rational zeros. So now when I graph this, I have 3x to the 4th minus x cubed minus 8x squared plus 2x plus 4. Now when I graph this, now I should see it intersect or cross the x-axis 4 times. Now if you look, I can kind of, this is going to be a little bit interesting. I may end up with not having a quadratic, or sorry, I may not have all of my zeros. There may be some irrational ones. So I'm going to go to the left of this, to the right of this, guess, and I get where this one says negative 1.414214. That's kind of a red flag. That tells me that it's not any of these here that I can just look at and kind of see. Because I know that negative 4/3 is going to be negative 1.3 repeating. So I'm not really confident on this one. So I'm going to skip past that one for now. Let's see if I can find this one here. This gave me a 0 at negative 2/3. So if I have a 0, so I know that I have a 0 at negative 2/3. That is helpful. That is helpful. Now let's go ahead and see if we can find these others. So I have one here. Looks like I have a 0 at positive 1. That's also helpful. And then let's see if I can find this other one here. I'm guessing that it's going to be, yep, it's another one of these scenarios. So what I'm going to do is I'm going to use synthetic division here in this idea or this content. Thank you, Storage Sense, appreciate that. I'm going to use synthetic division with these values to get this down to a quadratic that we can use. The negative 2/3 throws off students. Like when they see it at negative 2/3, it's like, well, what do I use for my synthetic division? Don't let the fractions confuse you. We would use negative 2/3. So let's do that one first. So again, synthetic division, negative 2/3. My coefficients are 3, negative 1, negative 8, 2, and 4. So now when I go through, bring down the 3. 3 times negative 2/3. It's going to be negative, what is that, 6/3? Negative 6/3 is negative 2. Negative 1 and negative 2 is negative 3. Negative 3 times negative 2/3 is going to be a positive 6/3, positive 2. There's negative 6. Negative 6, that's a positive 12/3, so that's 4. 6 again. I just did that. Negative 12 divided by 3, so negative 4, and I get a 0. And I should have gotten a 0. If I did not get a 0, that's a red flag. Now, because I used that negative 2/3, I can now use this value 1 here, and I can synthetic divide it again. This is going to take it from now it's a cubic down to a quadratic. So if I use 1 here, synthetic division with a 1, again, bring down the 3, is 1, that's a 0, 0, negative 6. Negative 6 times 1 is negative 6, and then that should be a 0, which we know from earlier. So then this is a quadratic. This quadratic is 3x squared minus 6. So I can use any method that we have to solve quadratics to figure out what these last zeros are. I know without a b term, it's actually easier to do the square root method. So if I set this equal to 0 and then solve, I'm going to add 6 on both sides. So plus 6 plus 6. So this gives me 3x squared equals 6. Divide by 3, divide by 3. I get x squared equals 2. So now when I do square root, plus minus, so I have x equals plus or minus square root of 2. So that gives me all of my zeros that I have from earlier. So there's 4 zeros, 1, 2, 3, 4, and that also satisfies this as a 4th degree polynomial. We do want to write it in completely factored form. So again, that last part is then putting it into factored form. So this is going to be p of x is equal to, so here I have x, this negative 2/3 also throws off students. Again, if I add 2/3 plus 2/3, then that negative 2/3 is canceled. A lot of times what you'll see though is you'll see, especially on the ACT, it'll want this as non-rational numbers. It'll want it as integers. And we'll talk about how to do that here shortly, how to convert it to integers. But let's finish this out first. That's x minus 1, and then I have, in this case, because we have this part here, this plus or minus square root of 2, you can do x minus square root of 2 and x plus square root of 2. It's kind of a little bit messy. So when I convert this one into its integer form, we'll talk about how that looks kind of cleaned up a little bit nicer. So let's talk about this as an integer form first. Essentially what you're doing when you're taking this part or this value here, you have a coefficient with the x. And this is where you're seeing problems that have like 3x plus 2 in this case. So let's just talk about how I got 3x plus 2. I picked a number kind of random out of my head. The coefficient is your denominator. So in this case, the coefficient of 3 was your denominator of 3. The numerator is then what you're adding on. If I plug in negative 2/3 into this, negative 2/3, if I plug that in, I actually end up with a negative 2, and negative 2 plus 2 is 0. So that's a way to convert it into integer form. Your other values then are going to be the x minus 1. And then you'll also see, for example, where it'll say x squared. Ooh, let's talk about that. X squared minus 2. Now, the reason why it's x squared is because, again, on the ACT, you'll want it as a factored form without irrational numbers. And so the square root of 2, remember, square root of 2 is irrational. That's why we got that kind of that off-looking decimal. That's actually the square root of 2 rounded. And then this would be what you would see kind of on the ACT where it says, list them all out as integers without any irrational numbers or just list them out as integers, and then you'll see that. There's an example of that. For time purposes, I'm going to do number 8 in the next video, so you have that all together. So I will see you in the next video.